Remember from before with transverse stability, there are some important reference points that are used to perform stability calculations. There's the keel, marking the lowest point on the ship, a center of buoyancy, marking the center of the ship's underwater volume, the center of gravity, marking the point at which the ship's mass is evenly distributed in all directions, and the transverse metacenter, which is a theoretical point used in stability calculations. Until now, we've only been looking at the ship in terms of its transverse, or side-to-side motion, to analyze how it will roll under certain conditions. Now, we can start looking at the ship in the fore and aft direction. Longitudinal calculations are done separately from transverse calculations, but a very similar set of reference points are used in both directions. First, there is the keel, which is still represented by the letter K. In longitudinal stability, any measurement that is taken from the keel is usually taken at amidships. Then there's the LCB, or the longitudinal center of buoyancy. Just like with transverse stability, it's the volumetric center of the underwater portion of the ship. Above that is the LCG, or the longitudinal center of gravity. Both of these points are really the same points that we were looking at with transverse stability, only now we're looking at their location in the fore and aft direction. When the center of gravity is moved forward or aft, the ship will pitch until the center of buoyancy is directly under the center of gravity. So as long as the ship is floating in water, the center of gravity will always be directly over top the center of buoyancy. Next, there's the longitudinal metacenter. This is actually a different point from the transverse metacenter, however it acts in a very similar way. Technically, it's the center of an arc that is described by the shifting center of buoyancy as the ship pitches or trims in the water. From G to ML is known as the longitudinal metacentric height. In longitudinal stability, this value is a lot larger than its transverse counterpart and can sometimes be well over 100 meters. When you consider this height, the center of gravity and the center of buoyancy are actually relatively close to each other. This means the length from G to ML and the length from B to ML can usually be interchanged in longitudinal calculations without causing enough error to matter. However, if you know the heights of these points above the keel, you can easily figure out the exact GML from the BML by adding in the KB and subtracting the KG. To calculate the BML, there's a relatively simple formula. The ship's BML is the moment of inertia of its waterplane divided by the volume of its displacement. This formula works for any ship shape, but can also be rearranged for simpler box-shaped vessels, such as Great Lakes freighters. For box-shaped vessels, the formula becomes BML equals the ship's length squared, divided by 12 times the ship's draft. Next, there are some terms that have to do with the dimensions of the vessel, starting with the perpendiculars. The aft perpendicular is drawn at the rudder post, and the forward perpendicular is drawn at the point where the summer load line intersects the stem. The perpendiculars are used as reference points for naval architects, and when we talk about the ship's length in stability calculations, what we're really talking about is the length between perpendiculars. Next, there's amidships. Amidships is located exactly halfway between the forward and aft perpendicular, and is represented by this symbol. Finally, there are the drafts: forward, midship, and aft. Drafts are quite simply the depth of the bottom of the keel below the surface of the water. When a ship gets lighter and floats higher, drafts are decreased. When it gets heavier and sinks deeper, the drafts will increase. When the ship is not on an even keel, and drafts forward and aft are different, the ship is said to be trimmed. This vessel is trimmed by the stern, because the after draft is deeper than the forward draft. The amount of trim is considered to be the difference between the forward and aft draft, which in this case is 3 meters by the stern. Finally, there's the mean draft. Mean draft is simply the average of the forward and aft drafts, which in this case is 5 meters. Mathematically, it works out to be the same as the draft midships. However, this is not as straightforward as it seems, as we'll see in the next lesson.